Hello there, cutie patootie, math angel. Welcome back. And yes, that includes you. And a very warm welcome to Decaf-Math ASMR if you are new here. Today we are going to take a look at multiplication, but with numbers past our 12 by 12 times tables. So this is a general foolproof way to multiply larger numbers, and you can apply this for some of our numbers in our times tables as well. Okay, so just like how we had a video for long division, this is going to be long multiplication, I suppose. So we're just going to take this step by step. It doesn't matter whether or not you know this. It doesn't matter whether or not you've learned it before. And I really don't care whether or not you like math or hate it or are unsure about it or whatever. I'm just here to enjoy. And I hope that you'll play along if you feel like it. Or just relaxed. Or even drift off to sleep if you need the rest, okay? The rest. So, we're going to take this step by step. Be patient with yourself. And let's take a look at how to do this without typing the numbers into a calculator or a phone. So for today, I want us to focus on just the how-to. So there are deeper concepts embedded in this as we go, and we can always revisit this and look at why. But for now, my goal and hope is that you leave here feeling like you have the tools and the confidence to be able to carry out or practice carrying out a larger multiplication question, okay? And of course, this is a video. You can always pause and practice. You can always come back to this at another time, or whatever it is that would bless you. But that's going to be my goal for today, because I think sometimes we try to take on too much all at once and we overlook a first little step. So take the step that you can take and let the rest wash away, okay? So let's start with a smaller number first, or two smaller numbers first, so that we can get a feel for how this works. So we are going to have two numbers that are multiplied together or by each other. So let's say I have 121 times 3. Okay? Just a first little example. So you may be able to just do this in your head, but for the purpose of this exercise, we're going to start writing it in this way. So I have my first number, and I'm going to put it like that, and then times, and then 3. Like that. So one above the other. And you want to line them up in this way so that we have the ones place, tens, 100s, and then the second number is just 3, which is 3 ones, so we just line it up under this one, okay? Usually we have the number that has the most digits on top. So if it were like this, it's 121 times 3, you wouldn't really write it like this. even though you'd get the same answer. This is a little bit strange to see, okay? And if they have the same number of digits, it doesn't matter. You just write one of them and then the other one, okay? But just for the sake of this particular question, we'll write 121 times 3. Now, what we do is we start here and we're moving up. Da, da, da. That's it. So we start with this 3. We multiply it by the 1 here. 3 times 1. Now, because we are going to be working with this digit by digit, it is important to know your times tables up to 9 times 9. And because order doesn't matter with multiplication, you only really need to memorize half of it, because, for instance, 4 times 8 and 8 times 4 are both 32. So you only have to memorize half. But here we have 3 times 1, so that's 3. So I write that here, okay? And then I do 3 times 2. 3 times 2 is 6. So I'll write that here. 3 times 1 is 3. So I write that there. So in this case, it's doop, 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 363, which you may have gotten just by looking at this. Okay? So I wanted to start with a simpler example first. And what I mean by that is, let's do one where we have to do one extra little step here. So a similar question, let's still do the times 3, but now let's do 129 times 3. Okay? So here, again, you may have learned other tricks in school, shortcuts, approximating things. However you want to do this, it's totally okay. But again, this is just the longhand form, okay? So with this, let's say we have 129 times 3. Okay. So this is kind of the next little layer up from our 121. The reason that this is slightly different, again, we have our 3 digits lined up nicely with our 3 here. We go from this side to this side, so moving from the 1s to the 10s to the 100s, starting here. 3 times 9 is 27. Now this is where things are a little bit different. So before, with just a 1, 3 times 1 is just 3. So we just put the 3. But do I put 27 like this? No, I do not do that. I do not do that. So we look at the 1s part, and now we put the 2. It groups and regroups into the 10s. And this is where we have to do 27. So we put 7 here, and then we put a little 2 up here. Okay? So you may have worked with blocks for this, perhaps, and blocks and sticks if you are a visual learner. But again, this is the how-to when you just want to carry this out. But conceptually, you basically regroup your 27 into 2 10s and 7 1s. Now I do 3 times 2, which is 6. And now I add the 2 on top. So now I have 6 plus 2, which is 8 10s. And I go ahead and put that down now. So whenever you multiply, you're multiplying normally. But if you have something more greater than or equal to 10, 10 included, so you just put 1, 0, greater than or equal to 10, you just put a little number on top. and then you multiply as usual, but then add whatever number if you have it there. So it's not quite borrowing. When you do long subtraction, you borrow. In this case, you're adding. So 3 times 2 is 6, plus 2 is 8. Very nice. And so you took care of that too already, so you don't have to worry about it anymore. 3 times 1 is 3. So 129 times 3 is 387. So let's say that you forgot to put the 2 up there. If you just did this, 27, 6, 3, you would get 3, 6, 2, 7. That is way too big, okay? And imagine if this were also a 9, we would have 3, 2, 7, 2, 7. That's way too big. So a good little habit to build is when you get an answer, make sure that it kind of makes sense, right? We are doing 129 times 3, so 129 plus 129 plus 129. So that would not be 3,000 something or 32,000 something, right? So that's a good little habit to kind of check yourself there, but I hope that this is making sense. So when you multiply, you're still doing the ones. If it's greater than or equal to 10, you just put that piece over to the next column and then keep your ones here. And then you multiply as usual and then add whatever else you need. Now, if for whatever reason you have one that has like on the farthest this way, the largest one, if you have 3 times 9 is 27, if there's nothing else more here, you can go ahead and do the 27 and plop that down. So if it's your very last step, you can go ahead and do that, because otherwise you're basically pretending there's a 0 here and doing the 2, 7 and 3 times 0, 0 plus 2. So you end up having the 2, 7 anyway. Okay, so that's the first thing, getting the hang of regrouping to the next. In our case, we're doing base 10, so our next place, our next value place, okay, or place value. Okay, so that's one concept. Make sure you're comfortable with this, moving in the correct direction, right, going from ones to tens, 100s, 1000s, however large now, so your numbers can be as large as you want, and then getting the hang of writing your second number lined up directly under, and then getting the hang of multiplying from ones, which would be the far right, moving one at a time, and then writing out if you happen to have something greater than or equal to 10, then multiplying and then adding the regrouping, okay? Now, next little layer to this is when you have multiple digits in both rows. So let's start with the smaller value first so that we get the hang of this. So let's say 122 times 73. Okay? So again, this one has 3 digits, 1, 2, 3. The second one has 2 digits, and because it's 73, I'm going to line up the 3 here. So it's 7 tens and 3 ones. So I'm going to line them up like this, okay? So if I wrote it like this, it's a little weird because it's not exactly 730, and this 3, which is the ones of 73, is lined up with the 2, which is the tens of 122. So that's just going to get a little confusing. So it's much better to write it like this, okay? Alright, so first step, line it up nicely. Second step, we take the ones, so again we're moving bottom up, doop, doop, doop. Okay, one at a time. We start with the ones, so 3 times 2 is 6. 3 times 2 is 6. Again, those are less than 10, so we don't have to do our little regrouping trick. So we just go ahead. 3 times 1 is 3. Okay, so we have 3, 6, 6 for this first part, 3. Now we move on to the 7. Okay, so now we have 7 times 2. 7 times 2. Okay, now when we move from the 1s to the 10s, what we do now is we put a 0. So we're gonna keep 366. Then we move down. So here, we're onto this line. And when we do that, as we move to the next digit over, I place a 0. Okay? That is to represent the 10s because this is actually 70, but I put a 0 there. This way I can do 7 times 2 is 14 and carry on, just like we did for the 3. When we do the 7, we can still do, but I need a 0. If I have more digits, let's say 173, which we'll do in a little bit, we put 2 zeros and we go on as far as we need to. Okay, so I put a 0 automatically, lining it up. And then 7 times 2 is 14. Now, because that's bigger than 10, I do the 1 up here, regrouping, and I put the 4 here. Then I continue. 7 times 2 is 14, but then I have a little 1 there. So 14 plus 1 is 15, which is interesting. Now we have like a double little chain here. 15, so I put 1 up here and the 5 down here. And then 7 times 1 is 7, plus 1 is 8. Okay, that one's a bit tricky. Take your time with this. We go this way, this way, this way. And anytime we have something bigger than 10, we just go ahead and plop the first digit up here, take the 1's digit and place it where we need it to go, and then continue on. And then the last one is 7 times 1 is 7, plus 1 is 8. Very good. Now what do we do with these 2 rows? We add them. Yes. So now everything's nicely lined up and we can do a nice long addition video as well, which we have not done. But I think you can get the hang of this if you're watching this particular one. We do 6 plus 0 is 6. 6 plus 4 is 10. So we do the same little 1 0 trick. And now we have 1 plus 3 plus 5 is 4 plus 5 is 9. And then 8. So 8906. And so we have the multiplication step, but then we also have a bit of addition as well. So 122 times 73 equals 8,906. 8,906 or 8,906. Okay? Very good. Very good. So the key step here that I want us to focus on is the fact that we go with the ones first. Doop, doop, doop. Then we do the next digit, but don't forget that when we do that, the next line is going to have a 0, and we keep on adding zeros with every other digit that we do here, okay? Then we add them all up, again, carrying stuff over if needed, and then we get our final answer. Okay, good. And again, you may have approximation, shortcuts, or anything else that you might have learned in school, and that's all wonderful, but this is the kind of catch-all method. You can do this anytime as long as you know your times tables up to 9 times 9. Okay, so while we're on that, we we might as well, since we've done our 12 by 12 times tables here, let's just go ahead and confirm that we could do this for 11 times 11, because I said all we need is to know 9 times 9, and otherwise we can still use this method. So we have 1, 1, 1, 1. So starting from this one, 1 times 1 is 1, 1 times 1 is 1. And then I move over to this one to do 1 times 1 is 1. But what do I need here? I need a 0 because I moved over a digit. So 1 times 1 is 1, 1 times 1 is 1. Okay, so let's add. 1 plus 0 is 1, 1 plus 1 is 2, 1. And indeed, 11 times 11 is a perfect square, one of our squares, and that would be 121. Okay, so that's what I mean by being able to use this method for even some of our 12 by 12 times tables. Alright, so now we have all of the elements here, and now it's time to just put it together. How about we just try one gigantic question and we'll just see what we get, okay? Just going to make up some random numbers, and it gets quite tedious, but it's totally okay. What else are we gonna do? Okay, so let's try this, okay? 2873 times 965. How about we throw in even one more, okay? Huge multiplication. Okay, this is going to give us lots of practice with our single digit multiplication, our regrouping rule, our needing to add zeros, and just being patient one at a time, as well as a huge addition thing. So this is quite tedious, but we can also just relax and enjoy as we go, right? And let's see what we get. So we have this nicely lined up again. We have ones, tens, 100s, and now 1000s as well. So we're going to start, it's always bottom up, doop, 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 doop. So 5 times 3 is 15, good. So I'm going to put the 5 down, but the 1 goes up here, okay. So 5 times 7 is 35, plus 1 is 36, good. 5 times 8 is 40, plus 3, 40 plus 3 is 43, excellent, you already got this. 5 times 2 is 10, 10 plus 4 is 14, and because that is the last one here, we just go ahead and write 14. Good. Now if you're doing this on paper, you can just go ahead and doop doop doop, cross those out, because now we are moving on to the next digit. So we can cross them out, you can erase them, whatever. Let's go ahead and erase. I think we might run out of room here. Okay. So now we move on to the 6. What do we do when we move over here? We plop in a 0 and proceed. 6 times 3 is 18. So I go 1, 8. 6 times 7 is 42. 42 plus 1 is 43. Good. 6 times 8 is 48. 48 plus 2 is 52. Good. And if you need to write that on the side, that's okay. If you need to count on your fingers, that's okay. 6 times 2 is 12, plus 5 is 17. Okay, and because that's the last one going upwards, we just go ahead and write that in. So this number is actually going to be really large, right? As expected, because we have something in the magnitudes of thousands multiplied by thousands. So this is going to be quite large. and that's okay. So now we move on to 9. 9. So now we moved another digit over, so we plop in 2 zeros because this 9 is actually 900, but we can just focus on one digit at a time, and the 2 zeros takes care of that. So 9 times 3 is 27. We do the same, recollect, regroup, and plop. Group, plop, group, plop if needed. If we have just 1, like 9 times 1, we just go ahead and put the 9 without plopping anything and it's all good. But we have 27, 9 times 7 is 63, plus 2 is 65. Excellent. You've got this. 9 times 8 is 72, plus 6 is 78. Good. 9 times 2 is 18. 18 plus 7 is 25. Yep. 25, 18, 19, 20, 21, 22, 23, 24, 25. Okay. And then let's move on. This is going to be a lot to add up together. That's okay. We have a 1 now, so we moved over to the next digit, meaning we plop in 1, 2, 3 zeros, and thankfully it's just a 1, so 1 times 3 is 3, 1 times 7 is 7, 1 times 8 is 8, and 1 times 2 is 2. And now, my dear math angel, it is time for us to add this together. So we just add, and hopefully you wrote this out nicely where everything is lined up. And if we need to carry something, we will. So 5 plus 0 plus 0 plus 0, 5. 6 plus 8 is 14, plus 0 plus 0 is 14. So we carry the 1, put down a 4. 1 plus 3 is 4, plus 3 is 7, plus 7 is 14. So 1, 4. 1 plus 4 is 5, plus 2 is 7, plus 5 is 12, plus 3 is 15. And if you need to take your time there, that's okay. 1 plus 4 is 5, right? 5 plus 2 is 7. 7 plus, and you can regroup this, so 7 plus 3 is 10, plus 5 is 15. You can do it in whatever order you want, but 1 plus 1 is 2, plus 7 is 9, plus 8 is 17 plus 7 is 24. So 2, 4. 2 plus 1 is 3. 3 plus 5 is 8. 8 plus 8 is 16. And then 1 plus 2 plus 2 is 5. That is actually a pretty cool number. I did not plan this out, but it's pretty neat. 5,645,445. 5,645,445. Now, why would you want to do this? Well, you can now make your own ASMR math channel and show other people and make them happy and be happy yourself. And of course, you can now use long division to check by taking this number and dividing by either of these and hopefully getting the other one. So if you took this divided by 2873, you should get 1965. But you could also plug that into a calculator and or your phone or computer or something, or ask a friend to do this out and you guys can check. But either way, now you know that you could do this for any numbers at all. Of course, up to 9 by 9, you can just memorize that, but you can use this overall technique for anything past 10. So, I hope that this was helpful, relaxing, fun, for review or relaxation, and I hope that you feel like you have a start in some direction for getting more comfortable with this. Of course, with more practice, you'll get to multiplying very quickly and simply and comfortably, and all of this will just get quicker and quicker. Or you can just do it, of course, for relaxation. So I will see you around for more math very, very, very soon. More regular math, sleepy math, relaxing math, fun math. I hope that you'll stay tuned no matter the level. And first and foremost, most importantly, you are so loved.